Hi, today I will introduce our project, Memory Augmented XGBoost System. We also call it MaxBoost for fraud detection. Let's start by our introduction video.
Meet Rosie and Joe.
Let's check our balance, dear.
Some cheeky scammer thinks he can pull a fast one on our favorite grandparents. But what he didn't expect was fraud detection powered by lightning-fast XGBoost, or as we like to call it, MaxBoost. Within seconds, busted. Safe and simple, just the way Grandma and Grandpa like it.
You can't scam us anymore, sweetie.
We've got MaxBoost on our side.
So as we can see from these two pictures, fraud has been increasingly common in our daily life. Although banks take a lot of efforts to stop fraud, but even have a negative impact on our daily consumption. But still a quarter of Americans suffer from fraud last year. We do some market research on both fraud loss and detection market. So for the picture is for the fraud loss from 2023 to 2028. As we can see from the table, it's have a stable increase, and it's expect to have $43 million in 2028. And the second picture is for fraud detection market. The system market is you can see the green line is have a stable growth rate, which means it will growth a power function very fast. So for fraud detection system in the earliest stage, the market use rules-based systems, but fraud patterns has changed very fast. Every minute it have a new patterns. So this is not suitable. Machine learning models come to solve this problem, but it still have some problem like no explainability and low latency. So why does market change? Because of some partly because the policy, for example, EU AI Act and North America compliance. And based on this policy, we see some market signals. For example, 80% bank aiding expandable AI tools. Following is some big tech using the detection system. The one side is using neural network, for example, Visa, Stripe, and PayPal. Another side using XGBoost. It's more expandable. Big tech like Capital One and Ant Group use this. So this is an interview with a bank manager in HSBC about what would you prefer, like AI model or a traditional model?
I think AI could do better than people, but actually in my daily work, a rule-based system is more reliable because it's more understandable. I can see the main reasons a transaction is flagged, and I can explain it to my customers. And actually in HSBC, most of the customers are people around 40 to 60. So AI is quite new for them. It's very hard to explain the something
mechanism to
yes,
the
yeah, and a totally black box system that we can't explain to our customer would be hard for us to work with.
Okay, so these are the three models currently in the market that's being used. First is neural nets that we know is a black box. Second is the traditional rule-based system that is currently outdated, and the XGBoost is a newer detection system, but it cannot detect rare patterns on its own. So we asked a data analyst from a bank in Dubai, Emirates NBD, would you prefer a hybrid model in your bank?
So definitely yes, a hybrid approach where AI is supporting the human decision making, it would be a very ideal situation. A hybrid system definitely would help. We could learn from like rare or unusual cases. As such, it would definitely help detect fraud patterns, and uh, it will definitely assist in a different way because a traditional rule-based system that users have that we might miss, and AI might be able to detect that. So definitely, it's a good approach.
Now, coming to our model architecture, so after all the market research that we did, we came up with this architecture that would give us an edge over the other systems in the market. So, first one, we use memory layer to get repeated fraud patterns from the bank. Second, we use clustering to give our model structure. Third is using XGBoost. This uses supervised learning. So still we have an explainability factor, right? That is where we use SHAP that explains each field and their impact on the model. And basically we can explain each case by case. Now, the fifth one is isolation forest that sort of gives us, we can detect rare anomaly patterns. And the sixth one is GPU acceleration that helps us detect multiple transactions. So now coming to our ROI and cost reduction. So our model has fewer false positives, less manual review, and is real-time friendly, which builds our trust in customers. Coming to the experiment phase, we have our data sets. So most of the online sources that are there use this Kaggle data set that is transactions in 2013. Now what we did, since that data set is clearly outdated as we can see the change in the market, we use this PaySim that gives us, it's a simulator that gives us real world logs of mobile payment services. So we combine both this data sets.
And then since we already have our data set, we then compare our models to the three baseline model. They are one is typical AN, and one is short-term memory network, and the last one is graph enhanced XGBoost. And we can see that we measure the precision recall area under curve because the single accuracy cannot precisely measure the performance because in imbalanced data, the fraud is very rare. Like it's only a small percentage. Even if you predict all the transaction as legitimate, you still got a very high accuracy. So we use the precision recall error in the curve to evaluate the performance. You can see that the three baseline model, even if they perform very good on the cargo data side, but they still perform the precision is extremely low on our data set after training because they basically doesn't learn anything from the training. The precision is only about 0.01, which is only a little bit higher than our floor rate. And for our model, the max boost, we reach is 0.35, which is 1,000 times compared to the three baseline model. Also for the ROC accuracy, with the three baseline model are just around like 0.5 because it didn't learn anything from the training. And however, we reached 0.74. And ROC accuracy measures how well the model separates fraud from the normal transaction overall. And based on this, we also asked our interviewee another question, that is, what is the weakness of the detection system used in your bank? Because the protection, privacy protection, don't say anything about it, but we still can learn from it.
But I think the weakness is sometimes it blocks genuine transactions, which upset the customers, and sometimes scams still go through if the customer is one authorizing it under pressure.
Yes, that means we need a very high accuracy on the fraud detection. And we also use test cases to validate our model. And the test cases are all from another data site. They are all real transaction records. And compared to the baseline model, they only got 50% accuracy, which means they predict all the test cases as legitimate. The test cases are formed as two parts. 20 are fraud and 20 are a legitimate transaction. For our model, we reach 100% accuracy for all 40 test cases, and the average responding time is below 55 milliseconds. And here is our demo video for our system.
Okay, so this is this screen of our system. Currently it has no transactions, so I'm just going to run this file to mimic real-time transactions. Now this file contains 40 fraud cases and 40 non-fraud cases. So as you can see from the backend that our system has already managed to give us 100% accuracy, correctly predicting all 40 cases. And if I just refresh the screen, here now we can see that the front end has all 40 cases and has flagged 20 as fraud. So these are each transactions here that we have with certain information. And over here we've added these two labels that sort of gives us a comparison. One is what our system has predicted, and one is whether the transaction is actually a fraud or not. And over here we also have the fraud probability. So these things are added just for comparison to check whether the transaction is correct or not. So if we go in detail in each transaction, over here we can see that there is transaction details with more with all the fields basically. And over here we have the SHAP contributors, that is basically the fields that have contributed to flag this particular transaction as a fraud, and what is the impact of each particular field. So now this is the top 10 contributors, and down we have a raw JSON that sort of gives us all the fields and their particular impact.
Okay, that's all about our demo video. And so why competitors can't keep up with us? Because neural networks, they are lack of interpretability, and for the traditional machine learning, the rules breaks under the evolving fraud patterns. And currently, also some vendors, they don't offer the GPU accelerated system, so it makes their training and detection very slow. And the current models, none of them combine the memory and the anomaly detection, also clustering like us do. So that makes our advantages. We have higher interpretability, and we perform better in rare fraud detection, and also our cost is lower, and deployment is faster. Also, we are real-time friendly. And that's all for our Max Boost. Thank you for